Hello, geometry students. In this brief lesson, a review of side, 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 angle, side, hypotenuse, leg. The question says, determine whether the triangles are congruent, and if so, write a statement. Is the top triangle congruent to the bottom triangle? What I'm going to do is I'm going to look and see what I have, and then see if it's a valid method for proving congruence. I know I've got two angles, and I know I've got a congruent side because the side is always equal to itself. So it looks like what I have is angle side side. Whoops. That is not a valid method for proving triangle congruence. So my thought is that these triangles are not congruent. But of course I have the refuge of hypotenuse leg. Anytime you see a right angle, hypotenuse leg is probably going to be your best bet. And that's what's happening here. This side here is the hypotenuse, and I have a congruent leg, so this is congruent by hypotenuse leg. So my statement is going to be this: triangle ABD is congruent to triangle CDB by hypotenuse leg. How about this next one? I'm definitely not going to use hypotenuse leg, but I do have a similar situation here where I have a side is congruent to itself. So it looks like what I have is side, angle, side. Is side, angle, side a valid method? It is. All right, hypotenuse leg here. So this is congruent. So triangle XWZ. Make sure you go in the same order. I started out at the peak, went down to W, end up at Z. By side, angle, side. Side, angle, side. Look at the next one. Same thing. Are they congruent? Well, I need at least 3 pieces of information. So if you're looking at A, it looks like I don't have enough information. But just to be on the safe side, I know I've got 2 sides. These are vertical angles, so I know the angles, but they don't tell me anything else. So I'm out of luck on this one. I must have 3 pieces of information. Some people would say not congruent. I say you cannot prove it or determine, because they may in fact be congruent. I just don't have enough information to prove it. How about this one? Here are a couple of pairs of sides, another pair of sides, and also it's always congruent to itself, a side. So side, side, side. Is side, side, side a valid method? It is. There are only 2 that don't work. We've already seen one of them. So my conclusion on this one, triangle, let's say ABC, is congruent to triangle CDA by side, side, side. This is going backwards. It asks what additional information is required. I want to prove this using side, angle, side. I already know 2 sides. I also know, without them telling me, that this is congruent to itself. So I have 2 sides. I must have the included angle. So I must prove that that angle is congruent to that. That's what I would say. So how I write this statement is that if it's true that angle M, except I have to write 3 letters, is congruent to angle M using the other 3 letters, then these are congruent by side, angle, side. The answer to the question is right there. If that's the case, then that is side, angle, side. I like to write it as a statement because it's not saying that it's true, but if it were, hypotenuse leg on this one, I've already got the right angle. It looks like I've got a leg. What I need to prove is that this and that are hypotenuses and that they are congruent. Well, if it's true that they are congruent, then this would be true by hypotenuse leg. I don't know if they're congruent, but if it's true that they are, then hypotenuse leg. So the answer to the problem is if the yellows are congruent, then that would be a congruent triangle. Same thing. What additional information? In this case, again, I want hypotenuse leg. I know the right angle. I know one of the legs. I must prove that KL is congruent to VW. If that's the case, then those are congruent. So if it's true that KL segment is congruent to VW segment, then these two triangles would be congruent using hypotenuse leg. How about this last one? I need to know side, side, side. Well, they've already told me one pair of sides. I know that Vx is congruent to itself. So what I need to prove is that this is congruent to that. If it's true, I'm not going to put red hash marks because I don't know if it's true. But if it's true that Wx is congruent to Cx, then these two triangles would be congruent using side, side, side. And that's that.